All right, Math 2, here we go. We got a short one. We got lesson 3.2.2, constant ratios in right triangles. So on this one, we're going to kind of look at what we were doing in the last lesson where we were noticing some ratios with the slopes, and we're going to kind of expand that. So in the last lesson, we were doing this page here, and we noticed that when we had an 11-degree angle, it looked like we had a constant slope ratio of 1/5. And we saw when we had a 22-degree angle, it looked like a slope ratio of about 2/5. And when we had an 18-degree angle, it was 6/19. And then a 45-degree angle, we saw that the slope was the same for the change in y and the change in x. So we had a slope of 1. So we're going to use those numbers today to show how we can solve for sides when we know the angles. So let's write down some of those slope numbers. So when we had the slope for an 11-degree triangle, we saw that the ratio of the slope was 1/5. When we had a slope of a 22-degree angle, we saw it was 2/5. We saw a slope of a, was it 18-degree angle? Let me look it up. Slope of a, 18-degree angle. We saw that it was 6/19. And finally, we noticed that when we had a slope of 45 degrees, we got a ratio of 1, or 1/1. All right, so we're going to use those ratios because we know that every right triangle that has 11 degrees in it is going to be similar to all the other right triangles. So here we've got the 11 degrees. Here's the change in y and the change in x. But we know that the slope of 11-degree triangle, the ratio for the change in y to the change in x should be 1/5. So I'm going to start with 1/5. That's kind of like my scale factor. And then y/20. So I can do cross products, or I can just look at it and say, okay, I'm multiplying 5 by 4, so I have to multiply 1 by 4. So either way you do it, you'll find out that you get 5y is equal to 20. So y must be 4. All right. Now I do want to mention that the slope of 11 is approximately 1/5. That's not an exact number. We're kind of fudging a little bit. The exact number has a lot of decimal places, but it's really, really close to 1/5. So we're just going to pretend for right now that it's about 1/5. All right, slope of 22 degrees. We said slope of 22 was 2/5. Okay, so the slope of 22 is 2/5. So I can do y/25. Now I can look at it and say, okay, I'm multiplying by 5 here. So I multiply the 2 by 5, and I should get 10. But we'll just go ahead and do cross products because it doesn't always come out nicely like that. 5 times y is 5y. 2 times 25 is 50. Divide by 5, and we do get y is 10, just like we said we would. Okay, next one. Slope of 11-degree. We said it was 1/5. My change in my y value is 100. And the change in the x, we don't know. Cross products. So we can see here that we're going to get 500 for x because 1 is being multiplied by 100. So 5 should get multiplied by 100. Cross products, I get 1 times x and 5 times 100. So yeah, x is 500. Sweet. Moving on. Told you it was fast. All right, slope of 45 degrees. We said the slope of 45 degrees was 1/1. So for this one, 1/1 equals 13/a. So yeah, a is going to be 13. So cross products, a equals 13. Over here, now we don't know. So theta is kind of like a variable that we use for, so this is a Greek letter right there. So we use theta a lot just to represent a missing angle. I don't know why. We just do. So if I wanted to find the slope of theta, it should be equal to 4 over 4. Now 4 over 4 is 1. So which kind of slope or which kind of degree measurement gives me a slope of 1? Well, up here I can see that 45 gives me a slope of 1. So theta must be 45 degrees. We didn't really need that on that one because we can see that if these are the same, this is an isosceles right triangle. And in an isosceles right triangle, these two angles have to be 45 degrees because if these two sides are congruent, these two angles are congruent. So using triangle sum, we'd know that those have to both be 45. All right, so here's another one, theta. So the slope of that angle is equal to 20 over 50. Now 20 over 50 reduces to 2 over 5. So we look up at our angles and say which one gives us an angle measurement of 2 over 5. And it looks like the slope of 22 gives us 2 over 5. So theta should be 22 degrees. Over here, 79 degrees. That's different. So if that's 79 degrees, then this, by triangle sum, has to be 11 degrees. Okay, so I can do the slope of 11 degrees is equal to 1 over 5. So when I do the slope of 11 degrees, it's kind of off right there. We'd have to kind of spin our paper a little bit and go, okay, this for 11 degrees would be the change in y, and this b would be the change in x. So this is one way to do it. So we would say 1 over 5 equals, 7 over b. Got the hiccups all of a sudden. We get b is 35. Now that's one way to do it. The other thing that we talked about in the last problem is that when we have complements, the last notes, so these two are complements that add up to 90. What we see is when we have this, when we compare the slopes of the complements, we get reciprocals. So if the slope of 11 is 1/5, the complement of 11 is 79, that would be the other angle, then we just flip this one and get 5 over 1 instead. So instead what we could have done on this one is the slope of 79 degrees, which is the complement of this one, is the reciprocal, because the y becomes the x and the x becomes the y. So we can just say that 5 over 1 for this angle, this is the y and this is the x, so 5 over 1 equals b over 7. And we still get the same answer. B is equal to 35 when we do cross products. All right, Sheila says the triangle in part F is the same as her drawing. Yeah, it's the same. 11 degrees, 79 degrees, 90 degrees. The 7 is between the 79 and the 90. It looks like Sheila has rotated it and reflected it a little bit. It's the same triangle, just in a different orientation. So that's true. Do we agree? Yeah, she's right. We can say that it is true by angle side angle if we wanted to. So they're congruent. By angle side angle, because I got 79, 7, 90 degrees. 79, 7, 9 degrees. Those are congruent triangles. What is the slope ratio of 79? And we were talking about that. The slope ratio of 79 ends up being 5 over 1. So the slope ratio for 79 is 5 over 1. What is the relationship between 11 and 79? Those are complementary. And what we were just saying in that last problem is that when we have complementary angles, the slope ratios are reciprocals. Meaning that if I've got the slope of 11 is 1 over 5, the complement would have 5 over 1. And that works every single time. So over here, when I said that the slope of 22 is 2 over 5, the complement of 22, so complement, remember, means they add up to 90. The complement of 22 would end up being 68. So the slope ratio of 68 degrees would be the reciprocal, 5 over 2. We could do that with 18 as well. The complement of 18 is 62. So the ratio of 62 would be 19 over 6. All right, that's all I got for you. Nice stuff. All right, see you later. Bye-bye. Math hard.